Hey everybody, Lars here. Tonight's a fun night. Tonight I am going to go on the web and show you Project Euler and tell you the story about how we used to use Project Euler to help teach kids Python, but then it turned into a university problem-solving club. And then what we're going to do is we're going to go to Project Euler and we're going to look at one of the problems and we're going to actually solve it using some of the things we've been learning in Unit 2, specifically lists and loops. Less lists, more loops. But we are going to tackle one of the Euler projects. First, let's go take a look. I think I have it looped up. Yes, I do. Project Euler, it's pronounced Euler, not Euler, and I learned that when I was a kid. I was actually corrected in front of an entire class of students by a math professor when I was in college, so I was made to look like a horse's ass in front of the unwashed masses because I did not know how to pronounce this man's name. This site is about number theory problems. And if we go to the section, well, first we're going to sign in. Basically what I've done is I created a user ID for us. 960. Let me sign in. Fantastic. So you can see we're PMDS, Spring 2016, signed in successful. And if you go to the archive section, you see lists of problems. Okay? I think if we go to the last one and we go to the bottom, you can see that there are 536 problems at the Project Euler site. So we are going to go to the first rack, because we are mostly concerned with problem number 6. But before we get there, I'm going to tell you the story. The story is this. Back 4 or 5 years ago, you guys know I run the Cave. It's a collaborative lab for the computer science department. And we would have kids come into the lab and say, hey, we want to learn Python. We want to learn about Python. We're hearing a bunch of good things. But at Rutgers University, there's no classes to, take in order to learn Python. And what we would tell the students was we would tell them, go do the 50 chapters or however many chapters it is at Learn Python the Hard Way. And Learn Python the Hard Way, even though it was 2.7 and not 3 star or whatever, would run you through the basics of printing and then simple arithmetic and then if-then and then loops. And it sequenced things pretty well. And by the time you got to the end of that 50, you understood a lot of programming concepts. And after that, we would tell students to go to Project Euler and do, say, the first 50 problems. Because something you're going to learn about Euler, and I guess I'll show you right now, is that the Euler site keeps a whole bunch of statistics on how people do and how many problems they've solved and how many they sign up for. And what you learn real quick is that if you solve 50 problems, it puts you in like the top 7%, the top 6% of people who use the site. We thought that was pretty good. Right now, what we would probably do for our club is we ask people to solve 58 so you can be in the top 5%. And then we'd call you 5%ers. But there's all kinds of stats here at the Euler stat. You can see how many countries are participating in Project Euler and how many different countries are solving the problems. And there's a lot of neat stuff here. I mean, there's a lot of content to read about Euler the mathematician, what he did. But most programmers, at least, concentrate on the problem. So you can go to archives and look at all the different problems here. Now, we would tell the kids to do either the first 50 or the first 60 or whatever. So it became pretty popular. So about a year ago, I guess maybe a year and a half ago now, I created a seminar series that I ran out of the Cave called Just Euler. And we would talk about problem solving and different number theory problems. And it morphed into students giving themselves interview problems. And a couple of kids took it over and actually turned it into a university club. So there's a university club now called Just Euler that's basically a problem-solving club based out of the computer science department. And what they do is there's a book called Cracking the Code, which has a bunch of interview questions for computer scientists and computer science interviews, programming interviews, and they solve other problems, and they still do Euler problems. So it's actually turned into a university club, which is very cool. They meet in the Cave on Tuesday nights. I go as often as I can just to sit in, just to see them, just to see what's going on. And it's really fantastic what these kids have done. So anyway, like an ad hoc stealth method for us to teach our kids Python 3 or 4 years ago has actually blossomed and turned into a university club where computer scientists get together and solve problems. Because like I've said it before in a bunch of other places, I don't know if I've said it with you guys yet, once you learn these techniques, if you're a computer scientist, you want problems. More problems, more problems. That's the lifeblood. That's food. Problems are food for computer scientists. You pick them apart. You see how to work this, how to work that. Oh, I can do this, I can do that, I can do this. So what we're going to do, now that I've showed you the site, is we're going to go look at one of the problems and actually use what we've learned so far to solve it. Now, I'm going to go to number 6. And you're going to see it's not the toughest problem in the world, but it's fairly interesting. The sum of the squares of the first 10 natural numbers is 1 squared, 2 squared, add it all up, 10 squared, 385. Then flip it. The square of the sum of the first 10 natural numbers is 1 plus 2, blah, blah, whatever, squared equals 55 squared equals 3025. You find the difference of those two numbers, and you get 2640. Okay? So that's 2640 is the difference of those two numbers if you do it with the first 10 natural numbers. What Euler asks us to do is to do it for the first 100 natural numbers. Now, of course, you could sit there with pen and paper and add it up, or a calculator, blah, blah, blah. That's not the point. Most of these Euler problems, and why it's good for people learning computer science, is that these things easily lend themselves to becoming computer programs, and this one is no different. We actually have a worked example here, and we can figure out the algorithm for solving the problem. And when we use loops, we're going to see that we can create a loop for 10 and see if we get the right answer, and then all we have to do is take that same loop and run it for 100. Now, when we come to an answer, we're going to come here and put it in, and we're going to click check, and we're going to see if we got it right or not. First thing we're going to do now, starting from scratch, is fire up Python. And then I am going to grab a new file. And right off the bat, I am going to save my new file. And I will, let me throw it in Google right now. PMDS, Unit 2. I'll call it examples. Nothing in examples right now. I'll call it Euler. I still say Euler. Euler 6.py. And I will save. All right. You know me in comments. We got to comment. So we know what we are doing. This is a comment. And then I will say author Lars. And then I will say working out Euler 6. All right. We got some comments. Now, what's the first thing we have to do? We look here. The sum of the squares of the first 10 natural numbers is 385. So the first thing we want to do is find the sum of the squares. And in our case, we're going to do things for 10 and then see if we get the right answer. And then we'll just go back and change our loops to do it for 100. And we should be. All right. Let's go find out. So sum of the squares. So let's say I want to call this sum of squares. And I'll make it equal to 0 at first, and then I will say for I in range, I want to start with 1. I want to go to 11 because 11 is the first thing I don't want. I want 1 to 10. And what am I going to do? I'm going to say sum of square is equal to sum of square, because what is this? It's an accumulator. We want to add up all the things in this range. But what do I want to add? Do I want to add I? No. You know why? Because I want it squared. So I'm going to add I squared. And what am I going to get at the end? I'm going to get the sum of the squares. But let's check ourselves as we go along. Sum of squares. No. Yes. Good. Good. All right, sum of squares, 385. You know what? I happen to know that I'm good there because I've got 385 sitting right there. All right? So I know I'm good there. What's the second thing I need? The square of the sum of the first 10 numbers is that. So how do we go about getting that? let's say square of sum equals 0 for I. We can use I again. That upper loop is over, so this variable is available for us to use in loops again. From range 1, 11, because that's the first thing we don't want. Now what am I doing? I want square of sum to, how about putting the F there, equal square of sum plus what? Okay, this time we do want I, because we want to add them all up first. And then after we're done with that, we want to square it. So now that we've got all that, we're going to say square of sum equals square of sum squared. Okay, so then we're going to print square of sum cross your fingers. Look at that. 3025. And we are correct. So now the very last thing we have to do is say print the difference is, and then we'll just do it right here in the print statement. Square of sum minus and what did we get? We get 2640. Is that the answer? 385, 2640. 385, 330, 25, 2640. Okay, so from 1 to 10, we have coded a solution where, I get rid of that line, where we're getting the answer, and we're doing it with our Python program. Okay, we're in Fat City now. We're not there yet. We're one step away, actually 2 steps away, but we're going to change that. The bottom over here says find the difference between the sum of squares for the first 100 natural numbers. Okay, so that for us, because we're computer programmers, is easy. In this range here, instead of 1 to 11, 1 to 101. Here, 1 to 101. Now, after just those 2 changes, I rerun it, and I get these numbers. Now, we're going to hop over to Euler in a second and see if that's correct. But I think there's one more thing I want to do here. You saw that I went and changed those numbers in 2 places, right? Well, I don't necessarily want to do that every time. What if I forget? Or what if I'm writing a big program and these 2 things are in different spots? And it's not a good idea to make changes in a bunch of spots when I could just make it in one. So I'm going to set a variable, and I'm going to call it limit, and I'm going to make it equal to 10. And I'm going to use it for the second half of my range when I do my loops. But there's a problem. What's my problem? Does anybody know? Don't yell it out because I can't hear you. This is a YouTube video. All right, what's the problem? The problem is I set my limit to 10 because I want to go to 10, but this is the first thing I don't want, okay? Because at the end of a range in Python, I'm exclusive. So we can just say +1 and fix that right there. Now, if you remember and you're a Python programmer and you're doing things, I could have always made this 11, okay? But usually we want to set the variables to the things that we want logically, and then we can make that exclusive change here in the loop. So now I have a variable called limit, and I use it in my range to give me 10. So when I say 10, okay, I get the old numbers that I got before. But now all I have to do is add the 0 and change it in only one place. And then both of my ranges are affected. And then when I rerun it, I get the answer right there. Okay? Now, let's go see if the rubber hits the road. I'm going to take this answer, 25164,150, and I am going to copy it to my clipboard, and I'm going to come in here to Euler, and I see my problem, and I say answer, and I paste it in there. Now, I put in the confirmation code because Euler doesn't want people using bots, so they want to make sure you're a poison. And then I'm going to hit check. And what Euler's going to do is check to see if I'm correct. You ready? You ready? Wait for it. Wait for it. Oh, taking a while. Oh, and there's the payoff. And I always say there's a nice buzz when you get that check doing Project Euler. We were correct. This is the correct answer to problem 6, and a whole bunch of people have solved this one. Now, as a disclaimer, what I have done tonight for you in this video is completely wrong. And I mean wrong morally. The answer is correct. But what they tell you about Project Euler is you should not advertise the answers to the problems, because then students, people who want to do them, they come to the site. They don't want to know the answers already. You want to make sure these problems are pristine and people know. There's a whole bunch of sites out there. And if you Google around, you'll know and you'll find them all that have solved a lot of these problems, and the solutions are out there. Now, I pick a very simple one, and I don't do any others. So I've wrecked problem 6 for the planet. I'm going to stick with just problem 6 and just own that. And I'm not going to do any more. But technically, you're not supposed to publicize solutions to Euler problems, be it on the World Wide Web, at a place called Stack Overflow, or on these YouTube videos, blah, 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 blah. But Euler 6 is a pretty easy one. I don't think anybody's going to, find my address and hunt me down because I've wrecked, Euler 6 for the world. Hopefully that's the case. I don't know. Okay, we have one correct. So now I can go to progress. And I can show you that we have solved 1 out of 546. And you can even see number 6 marked right here. So anytime you wanted, boop, you come here and click on number 6, and you can go, and it'll say, hey, this is when you completed it. This is the correct answer, and this is how it went. And you can now go look up your statistics, and you can find out that you're still not even a level 1 yet, because you got to do 25 to be level 1. And you can look at all of those things. And I'm not saying you use this silly one. I just did this for demonstration purposes. I'm telling you, Project Euler is free, so you should go sign up. Go sign up for an account and then try to do some of these problems. Some of them are fairly trivial affairs like the ones we just did, but some of them are clever and some of them are interesting. And all of them are going to test your skills as far as iteration and doing math and a whole host of things that have to do with computer programming. So it's really interesting and it's really cool. And whenever I do these classes, I make sure my students know about it because it's a great place to go and practice. And when you're learning a computer language, that's what you need to do. You need to practice, practice, practice with problems so you can see things in different contexts and get different problems and think about things in other ways. Remember, this is computer programming. You need to think about how to solve problems in discrete steps that take a data set and march you towards the goal state and get things solved for you. So that is the answer to Euler 6. And of course, as I always do, I'm going to take this Euler6.py and I'm going to put it up on Sakai for you guys. So if you want to grab it, you can grab it. You can play around with it. As you can see, real easy. We just set a variable and we used it in 2 loops. And in these loops, via accumulators, we calculated the numbers we needed to do our calculation at the bottom. And we found the answer to this Euler 6 problem, not for 10 natural numbers, but for the first 100 natural numbers. So I figured it's a contrived math problem. Yeah, I get it. But it's a real problem. It's out there on the web, and we just used computer programming in Python to solve it. So I figured that's pretty, neat thing. It's next level stuff. I wanted you to see it and know that you now have enough tools in your toolbox that you can start attacking things. You're a novice, but you're not that much of a novice. You can go out and start, using programming to do things, all right? I'm not going to kill you with announcements. It's Thursday. The unit is winding down. I already see people handing in assignments, which is a good thing. Make sure and watch that Slab and Talk and post in the forums. Those are easy points, and you want to make sure you get those points. And just start now reading all the materials and get ready for the quiz. The quiz won't be a backbreaker. And we're going to end the unit in the beginning of next week and get started with Unit 3. I'll probably do I'll probably wait until next week and start off with a Unit 3 video. And then Next week, I will probably do review videos for the assignments because I want to go over the assignments real quick and show you how I would have done them and how they're done. Okay? So don't worry. You know me with announcements. I'm very verbose. I will be in there every other day telling you what's going on and dropping deadlines for you, all right? So I hope you enjoyed this. Project Euler is definitely a great place to practice and a great place to use the Python that you're learning, all right? You have a good night, and I'm getting out of here. I'll talk to you later.